Hear me? Today I will give you a brief introduction of the project CommONEnergy that, as Marine said, it was a very long project, 4 years. So this project has been carried on by 23 organizations between industry, small, medium enterprises, research institutions, universities, and so on. So we had some very challenging targets. First of all, the objective of this project was the reconceptualization of shopping malls throughout deep retrofitting. We introduced some innovative technologies, and we try to combine these technologies to reach some very ambitious targets, like 75% reduction of energy demand, power peak shaving, but 50% of increase of share of renewable energy sources in 7 years of payback time, and all of this with an improved indoor environmental quality as one of the main targets. Some numbers about the projects. There were 3 demo cases, and we were 23 organizations. Shopping centers, they are particular case of building for many reasons, mainly for the energy used and for the reasons why this energy is used in shopping centers. They usually, first of all, are cooling dominated buildings, and there is a big difference between shopping centers with big grocery store inside and shopping centers without grocery store inside, as you can see in this bottom part in this figure. Roughly 80% of the total electricity consumed by a shopping center is ascribed to ventilation, lighting, and indoor conditioning. This is a big amount, and especially lighting play a key role in this energy consumption share. Another specific thing of a shopping center are the stakeholders. We have 4 stakeholders. There is the owner of a shopping center, there are the tenants and the customers. It's interesting this scale because the customers are the one that needs to be satisfied, and they need to be satisfied by the tenants with their shop and how this shop are laid out and so on. But they pay the rent to the owners, so there is already this chain. Plus, there is the community, which play another key role in this chain of stakeholders. Moving on, there is this interesting figure that show how a shopping center, a shopping mall owner perceive the analysis of our possible retrofit in a shopping center and how it actually impact a shopping center. So usually an owner looks from the economical point of view a retrofit, and they look at the economical part, everything related to employees, customer, and so on, and they after a retrofit, they change the experience, moving in this way, of the employees and of the customers. And at the end, there is a change also in the internal environment after a retrofit. But actually, the impact moves on this way. After a retrofit, you change the environment, you change the lighting, the environmental quality, thermal comfort. This change the experience of the employees and the customers, and then it has an impact on the economics aspect of a shopping center. Another interesting element is this that shopping center renovation rate is about 4.4% a year. If you compare that to regular building, to, for example, residential sector, in Europe, the renovation rate is 1%. So we have this kind of a very fast and running train on which we can jump in and try to push for energy efficiency solutions to be included in this renovation of shopping centers, because it's very often that this renovation is not led by reasons of energy saving, but they are led by reasons of aesthetical reasons, because they want to change the layout and so on. So if we take advantage of this and we promote energy efficient solutions, there is a big room for energy savings in this type of buildings. If we take a look on the shopping center building stock, we can see that in the Y scale there is the sale growth by between 2000 and 2012, and on the X scale there is the gross leasable area per capita. As you can see, the majority of the building in the building stock are on the bottom side of this chart. That means The majority of the buildings are in the part where the sale growth is low. That means they are existing buildings. So we are talking about the majority of the shopping center buildings in Europe are already there, and they have been there for quite some time. So there is a lot of space for innovation. And here is the place where the CommONEnergy project plays and does the big part of the work. So on the renovation part. In this project, we introduce 11 reference buildings, 11 reference shopping centers all around Europe, with many different characteristics, both from in terms of dimension, but also in terms of climates. As you can see, the buildings are spread all over Europe. But there are also very different typology. For example, there is one of the demo cases that is Mercado del Valle, an historical building, but there are also very new buildings like the Catanè shopping center that you will see a bit more later on, and so on. So we try to be diverse in the type of buildings that we selected in order to represent the building stock. And we use these buildings to analyze the building stock and to perform some analysis on the shopping center building stocks. The three demo cases, here I have a quick look on the three demo cases. There is the Valladolid, Mercado del Valle. There is a market in Spain. It's a historical building that has been renovated. There is the shopping center in Norway, in Trondheim, called City. This is a medium scale shopping center, and it's fairly new typology of shopping center. And then there is the shopping center in Modena in Italy. What we did, we promote this performance-based renovation analysis of the potential of the renovation of shopping centers. So what we did, we made shopping center archetypes. We analyzed the building stock, we analyzed the reference buildings that we have, and then we define the retrofitting potential, analyzing the performance, the innovation, the viability, and the cost. The results of the analysis end up in this repository that we made, and we had this repository of robust technology and solution set that can be applied as best practice in the reference buildings. And then we perform an energy and economical impact analysis. The results of this research can be used for future bill of material and so on. Let's take a quick look on the technologies that have been studied and developed within this project. Here there are between the technology we have something like natural ventilation. That is something that you don't see very often in a shopping center, but we promote that and we study and apply that. We study the daylight and advanced artificial lighting approach for energy efficiency, modular multifunctional climate adaptive facade, multifunctional smart coating, greenery interaction, panel for thermal and acoustic requalification, integration of solar collector, storage of battery. We studied the coupling between HVAC and refrigeration based on a natural refrigerant. This is quite uncommon to find in Europe in these days. And then finally, we analyze the use of IBEMS, that is a smart supervision and management of the shopping centers. But you will hear more about this later on. But also we developed some tools that have different scopes that can support both the operational phase of the shopping center, but also the design phase of the shopping center. For example, we had the integrated design process. We developed the integrative model environment. This is an environment to perform simulation in transit that is specifically made to analyze shopping center. We developed this economical evaluation and definition of retrofitting scenarios. This is for the first phase before to take a decision on the retrofit of a shopping center, to perform some basic analysis and see which are the most useful or the best retrofit that can be applied. There is the continuous commissioning platform. That is a platform that we develop for the after the retrofit period, so that the energy manager can analyze how the shopping center really performs and which are the actions that can be taken to improve the performance of the shopping center. And then there is the sustainability assessment tool. Finally, we develop also this guideline that I think is very useful for many players in this scenario, like designers, facility managers, and owners of shopping centers. In these guidelines, that is a very practical guidelines. This player they can find key information to guide their daily activities. Some final comments. Shopping center energy retrofits are highly replicable also for other typology of buildings and can be applied to basically all the European buildings, European shopping centers. In the retail context, sustainability is appealing only or mainly for a business perspective. This is another key issue. Sustainability has not a value as itself, but it has a value only from a business perspective in this for shopping centers. So we need to find a way to promote that also from a business perspective, from a business point of view. Shopping center specificities should be addressed in European directives, and this is not done yet. And after a drastic reduction of energy needs, shopping center could become a sort of energy hub. This is an interesting concept that is not that much investigated right now, but it's something that is worth to analyze and study for the future. Thank you very much.
Thank you, Wilmer, for this general introduction. Very interesting. I remind all participants that what is presented will be available on BuildUp, and the guidelines that Wilmer mentioned are already available on BuildUp, so I invite you to download them from there. We will now have the second speaker, Martin de Groot, who will give us a European perspective of the topic of commercial buildings in legislation. Martin is head of research at BPIE, the Buildings Performance Institute Europe, where he is working on very different topics like building performance policies, innovation in the construction sector, smart buildings, and working on many different Horizon 2020 projects, such as CommONEnergy, of course, IB Road, Exceed, etc. He was previously working at the Flemish Energy Agency in Belgium, and Martin holds a master's degree in industrial design and energy and climate postgraduate. Martin, the floor is yours.